Hello everyone and welcome to National Space Academy's Takeover Week. We are taking over the National Space Centre's social media channels to talk to some really cool people in the space sector. My name is Nat and I'm here today with Dr Chun Keat Yew. Sorry, I said that wrong, didn't I? Doctor, would you like to introduce yourself?
Hi, I am Chun Keat Yew. And so today I'm coming in from the Flood Innovation Centre from the University of Hull. Thank you, Nat, for the introduction. So do I start sharing my screen?
Yeah, sure. If you want to just introduce yourself and tell us a little bit about what you do and how you got there, that'd be great.
Okay, yeah, so I think I was chatting to Nat earlier on, and my involvement with the National Space Academy is slightly unique in comparison to a traditional, rocket scientist or a space scientist or an exoplanet scientist. My involvement with the National Space Academy was significantly later in comparison to a usual route of entry into the space sector. So today I'm going to tell you a bit about my background, and then also how I got involved, and then ending with the Flood Innovation Center where I am now. Let me share my screen. Share screen. Oops. Oh no, the computer is frozen.
Always the way, isn't it? What a nightmare.
Okay, well, I think you can see my screen. Resume share. Oh, okay, perfect. I think you can see my screen now. Okay, yeah, so my background, I was born and raised in Penang, Malaysia, and I came over to the UK in 2008 to do my undergraduate degree. So my background is in electrical and electronic engineering, so not your traditional space science sector subjects. And then, so I went on to continue doing a PhD in human movement energy harvesting. So that is completely, if you think about it, there's none of it talks about space or exoplanets or any of that kind. However, it's still core STEM. I did engineering, and then from my PhD, I then went on to do remote sensing and Earth observation research. So this is where my space relationship started. So within Earth observation and remote sensing, I was working with sensors and systems which were designed primarily for space use. So within satellites, so they were designed initially for satellite use, and then it is my job to then take these designs and then incorporate them into UAV or airborne flight-based systems. So obviously I was working with a lot of colleagues who are working on space projects, even for example, the James Webb Space Telescope projects. Some of them, they are based down in RAL, Rutherford Appleton Laboratory. And so these designs, a lot of very brilliant scientists, they work there, and it is my job then to convert these designs and make them usable within a commercial application within drones and UAV. I think we got the memo to say, show what our workspace looks like, and ignore the mess. And this is how an actual office looks like on the left. And then on the right is the lab which I used to work in. And so that is down at Rutherford Appleton Laboratory. And it's a brilliant place to work. And this is where, we do all our cool stuff. Ignore the mess. And then, so since then, within the process of adapting these designs, you can see that you completely redesign the whole thing, and this is where the core engineering skills come into play. So here you can actually see we've completely redesigned everything in computer-aided design in CAD, and then using our prototyping skills, we try and, using 3D printing to get our designs out a lot quicker, a lot faster, so we can then optimize it, update it, try it again. And so from there on, we try and fly these designs. And then when we collect our data, we then compare it with the space data, the satellite data that we actually get. So that is how my relationship with the space sector comes on and off. And this is all from remote sensing. And you do a lot of remote sensing from satellite and space designs, sensors. And so for me, it is airborne design, but with a space philosophy. And then you compare it with your satellite data to make sure they all correlate and they're all working together. And then so another sector that I come into play is I met Professor Anu Oja, who's the director of the National Space Centre, when attending conferences such as this one in 2015. This is the UK-China Space Technology Workshop. This was in Newbury, and here is Professor Oja, and that's me. So this is the first time we met, and the story goes where in 2016, we bumped into each other again at the same conference, and this time in China. And this is when Professor Oja approached me to say, Chun, I think there's something that we can work together on this. And he then introduces the National Space Academy Masterclasses, which is a brilliant program where teachers such as Natalie yourselves, physics STEM teachers, and they teach students in a completely brilliant way within the space context, and it makes science so much more interesting. And so I was involved in a lot of the National Space Academy's projects in China, partly because I could speak the language, and also because I was able to take the context, the space science context, and transfer it into a layperson's understanding. So I guess in a way where they could understand it fairly easily, and then also from a non-scientist perspective. So hopefully that helps them. And then so I've been on quite a few projects on these, in 2016 up to 2018. Obviously nothing happened last year because of COVID. And then since then, taking all these experiences, I now work at the Flood Innovation Center at the University of Hull. The relationship with space still continues, but then only in a data sort of way, because I've left the instrumentation design work behind. And then now this is solely focusing on helping businesses within the country, within the UK, and help them innovate and be able to take their products, services, and applications to a commercial level and protect us all from flood. Obviously, flooding is going to happen whether we like it or not. So we need to be prepared for it as much as we can. And so helping these businesses, starting with the Humber region and then slowly going out nationwide, hopefully we can then be able to help them and along ourselves with living with flood. So obviously here you can see from the flood side of things, flood risk is a huge, huge risk to the whole of the UK. So outside of London, the Yorkshire and Humber region is ranked number 2 on the risk category. So there are a lot of businesses, residential properties, as well as a lot of land, which are at risk of flooding. If we don't do something about it, it's going to come really, really quickly. So we work with a lot of stakeholders, for example, like the Environment Agency, who works with a lot of scientists and data sets, including satellite data sets, where they actually combine it all together and then be able to produce, for example, flood risk maps like these. And so, for example, if you have a STEM background, you will be able to understand these maps, and you can then work with them on a higher level or on a closer level to be able to, benefit your businesses or your target clients. So this is, for example, now my very quick workspace on a day-to-day basis. So very different to my lab and office structure now, although we're still based in offices, although we're working from home, but then in the labs, these are my labs now in comparison to the previous optics lab. So there we go. That's a very, very, very quick background and introduction of my involvement with the National Space Academy. Hopefully this helps.
That's great. Thank you so much for introducing yourself. So you said you're currently working in flood tracking and prevention, is that right?
Yeah, so we work with businesses who are, some of them are tracking and some of them are wanting to help us prevent as well as increase resilience within the flood sector. That's correct.
So how important is what you do? When we were chatting before, you mentioned that often the first thing people know about a flood is when it's at their door. So how important is it to be aware of this?
Yeah, absolutely, because I think flooding, it always only comes on the news when it happens. So it's already too late when people see water coming through their door. So it's really important where, for example, we can prep ourselves. I think the government's doing as much as it can. The stakeholders, for example, Environment Agency, DEFRA, they're also doing as much as they can. But us, ourselves, and businesses along, there's a market in place for us to be prepared. So there are a lot of measures that we can take, property flood resilience measures, as well as natural flood management resilience measures that we can actually take to actually help this process along. And using a lot of data, data now we're getting more and more data from many sources, including from satellites. So we can now actually use these data to actually help us.
And do you think that flooding is a problem that's going to become more and more important as we go along?
Unfortunately, with climate change and sea level rising, it is going to be a problem that we come across significantly more frequently, and we have to learn to be able to live with it and cope with it. And yeah, we have to start now. Otherwise it'll be too late.
So if you started to work with a company and you were developing something new, what sort of time frame would you be looking at?
So I think I'm going to split it into two. So obviously, if you're doing academic research, that will probably more often than not take a longer time frame. Whereas if you're doing a commercial-led research or commercial-led product development, you would want to be faster because you want to get it out to market a lot quicker. I think more often than not, your cutting-edge research is done within an academic setting, whereas your commercial one, it could take months, it could take years, but then it depends on the scale, depends on the sector, depends on what you're developing.
So you work quite closely with people within the space sector. And again, we were discussing before the fact that maybe you're a slightly less direct link than some of the others.
Absolutely.
So is it something you enjoy working closely with the space sector?
Yes, absolutely. So obviously, because I'm not involved firsthand, whereas I work with people who work firsthand within these sectors. And for me, it was actually quite important to be able to understand what they want in terms of requirements and what they need, as well as for them to understand what I can help them with. So it's having STEM education was really important, I thought, and then being able to communicate quite closely and quite openly at what you need, because I think our way of thinking might be very different to what the space sector is doing. And then so being able to understand each other, that was really, really important.
That's great, thank you. So could you tell us a little bit more about perhaps your journey then, how you got to this job, what you did before?
Yeah, so so before coming to the UK, I did obviously primary, secondary and college education in Malaysia, and then I came across to the UK. So English wasn't my first language, funnily enough, but obviously we speak it now day to day. And then so actually being able to speak more than one language actually helped me along this National Space Academy journey. So I came to the UK, I did engineering, and then from there on, I wanted to not be in a lab so much. I wanted to be able to, be on projects that have a difference, that make a difference, be it outreach, telling students and inspiring them that STEM education is really important, as well as being on projects that actually can make a difference and having an impact environmentally, something like that. And this is how, I made the decisions I did with my careers. So yeah, it was me wanting to have an impact, and that's why I made the decisions.
And I see you did a PhD, and I think the title is so interesting. Can you tell us a little bit more about that? I'll let you introduce it, because
yeah. So my PhD was human movement energy harvesting. It was completely different to space. However, I think the thought behind it was, I think previously we have pacemakers that within some people, that you need the batteries replacing every so often. And if you could prolong that period of replacing the batteries using, for example, human movements and gestures that we do. So for example, people have pacemakers, they can still do sport, they can still do walking, running, and so on and so forth. So why don't we use these movements to actually generate or take off a little bits of energy that can then be put back into the battery consistently over a long period of time, and by that you can then prolong the period of battery replacement, which then helps them live longer. So yeah, so that was that was the whole aim of the project.
That's really, I could ask you questions about that all day, because it's so what I do. So
no, absolutely.
But I won't, don't worry. So did you always want to do a PhD? Did you know that was something you always wanted to do, or?
I think it came quite clear when I did my degree, when the opportunity came along, I jumped at it. Initially, when I was still in school, in primary school, secondary school, I didn't really think too much about it. But then when I was doing my degree, when the opportunity came along, I then jumped at it. I was like, yep, let's do this.
So if there was someone who was perhaps in your position where they knew they wanted to do the PhD, but perhaps they were still at college or in their early undergraduate, what piece of advice would you give to them? What could they do to help them prepare?
Yeah, I think the most important thing is really liking it, because a PhD is a 3-4 year project. In actual sense, it is a project that you take ownership of it. I think the biggest change for me was you go from a completely structured learning program, for example, when you're in school, and in undergraduate, you have your timetables and schedules. You know, like 9 a.m. you do this, 12 p.m. you do that. Whereas in a PhD, it is completely unstructured up to a certain sense. So you then take ownership of being able to plan and learn, you know, put forth what you think is the most important thing. And this journey takes you 3 to 4 years, but then it's a really brilliant learning journey, and your supervisors and your colleagues will help you a lot. But then loving the topic and loving what you do and having passion for it, that's the most important thing that will get you through it.
So this might seem like a slightly obvious question, but was it hard?
Yeah, well, I think yeah, I would say so. I think it's supposed to be challenging. I don't think it's hard in one way. I think hard is quite a hard word. Well, that's the pun, isn't it? Yeah. I think hard isn't the right word to actually to actually describe it. I think in my experience, I would go, it's challenging, but on a different scale. But because you've had a longer time period to prepare yourselves, and because by your second, third, fourth year, you would be a real expert within that topic. But it's a very tiny topic, so you're very, very niched in. Whereas, you know, more people have general knowledge, but you have a very, very good idea of that one particular subject. So yeah, so I think, yeah, you should be confident in yourselves and absolutely go for it. Absolutely go for it. So it's challenging, not hard, I guess.
Yeah, that's a much better way of phrasing it, I guess. It's challenging rather than hard. I like it. So what was your favourite part about doing a PhD?
So yeah, I think the overall process of being able to prioritize what you think is important down the line. So this is coming off it completely and then going on to a new project. And then when you start a new project, you really need to understand how to apply the principles, because from my PhD journey, I went from working within the engineering department, going straight to the geography department. And you would go, my engineering colleagues would go, what is going on, you know? But then it is actually learning to be able to communicate with people from a different perspective, because geographers, remote sensing people, they look at things very differently. Scientists, you look at things differently, but scientists, you have different strands of scientists as well. You've got your engineers, you've got instrumentation, you've got your space scientists, you've got your rocket scientists, and everyone looks at a very specific thing differently. So it's really important to be able to communicate with them. And my journey taught me how to do that. And also being able to prioritize and communicate really well what are the important things and then what aren't the important things.
So you've mentioned communication quite a lot there. Are there any other skills that you would recommend young people to develop in order to do what you've done?
I think starting off, language skills I found was really important. I think it's given me an advantage in this situation, because I was able to speak a different language. I was able to be involved with a lot of National Space Academy's international work. That definitely gave me an advantage. But I think also making it quite simple and simple to understand, you know, like theories that are quite complex, that if you can just take it down a notch and make it quite simple and straightforward, that would be quite something that I try and do very often.
Great, thank you so much. And just a reminder that if you have any questions, you can pop them into our chat and I will convey them to Dr. Chun. So we talked a little bit about your PhD now, and then you say now you work in floods. It seems like,
where's the connection?
Yeah. How did you get there from your PhD?
Yeah, so a lot of it is transferable skills. So for me, transferable skills are really important. And then so being able to take what I've learned from my PhD journey, although not being able to continue doing that specific project, I was then able to transfer the engineering skills and the curiosity of science, and being able to apply that in an instrumentation way within Earth observation and remote sensing. So the transferable skills from there now comes onto the Flood Innovation Center, where I then look at a different subject. So I was doing the research aimed at commercialization. From this experience, I now trying to help these companies who are trying to build their product within a specific life cycle and help them take their product to market within the flood sector now. So it's just transferable skills. I think as young people coming up, I think it's important to have transferable skills, which then somewhere down the line, if you are not within the space sector now, you can still enter the space sector if you have transferable skills.
Oh, that's great. Thank you so much. So again, we've mentioned a few like communication and languages. What transferable skills would you say would be ideal for going into the space sector, perhaps?
I think it depends on what you want to do. So I think a lot of people see, well, I think from my experience, you look at, space sector, it means scientists, it means people who build satellites, people who build rockets. It's actually not, that's only one part of the space sector. You have a significant other bits of space sector, which is I wouldn't call it the support staff, but it's the professional staff. So for example, you have people within logistics, people within business and marketing, people within communications, even within IT, deployment, these and so on. So, even for example, if you're doing a literature degree, you can then still also work in the space sector by, providing training to the scientists. For example, teach us how to communicate better with people who are non-scientists. And you're still within that space sector. So that's really important. And being able to see past being in space is you have to be a scientist, you don't. But then having a STEM background is really helpful in this situation.
Yeah, I think that's such an important message, isn't it? That there are so many different areas of it and you don't necessarily have to be a rocket scientist. And I think you're a really good person to demonstrate this and talk about it so well. I just think it's a really nice message to convey. So we've had a couple of questions. Kieran has asked, are there other areas where remote sensing can help with environmental challenges?
Absolutely. I think remote sensing now, it's getting a lot better. It's getting, but then there are multiple levels of remote sensing. Obviously, you start from the ground and you go into UAVs, and then you go into airborne, and then you go into satellites. Obviously, the satellites, the space side of things, they cover a significantly wider range and width in terms of the areas that they're able to sense. But sometimes they don't have enough resolution or detail in their sensors. They're getting a lot better very, very quickly. However, you can then have the ones in between, the airborne ones and all the way to the ground, where they can give you significantly higher detail for what you need to do, but then they don't cover as wide an area. But then more and more data sets are being accumulated, being studied, and also being post-processed with new algorithms that will provide us with newer insights, newer trends, stats, and so on and so forth, which will hopefully guide us to a better way in the future.
And a follow-up question from that is it very different, do you think it's very different working with the companies that you work with now to working perhaps with academics as you have done previously? Yeah,
I think it's a very different mindset, because I think traditionally within the academic world, you kind of have this that it's a long ongoing process. Whereas with the commercial environment, you need to push this out to market straight away, especially with SMEs. If they're just trying to stay afloat, you need to get this thing out to market so they can then make more revenue to actually keep the companies afloat. So the concepts are actually very different. If there is only a way to help them talk more and be able to collaborate more, breaking down a lot of the barriers, traditional barriers in there, innovation would go a lot quicker. I think this is why me and my colleagues are employed to do the jobs that we do, because perhaps we've had the background within academia in some way or form, we've worked with them before, but then we can try and pick the good bits and apply them in commercial sectors and try and marry them two together. But yes, it's a very different sector.
So maybe I'm putting you on the spot a little bit here, but do you have a preference, academia or the commercial side?
Well, it's a combination of both. I think this is why I decided I didn't want to be in the lab 24/7. Whereas, so I want to be able to work on projects that have an impact straight away. Impact, you know, it could start locally, regionally, nationally, and so on and so forth. But then an impact is what I want to do. I want to be able to help people, be companies or within academia, to actually do that. So yeah, I would go both sides currently.
So do you think it's easy to make the transition between the two?
For me, I thought it was pretty straightforward. Maybe perhaps I was able to see in between the lines sometimes. But I think being able to immerse yourself and actually really enjoy learning new things, because every time you move to a different role, you have to learn new things. You pick up new skills, and then from there you try and make it into a transferable skill. And from there on, yeah, I thought I enjoyed the process.
Okay, and then there's two questions I always like to ask. I've asked everyone this week. Firstly, would you go to space if you were given the chance to do your job?
Yep. Yep, absolutely.
Yes.
Absolutely. Absolutely.
Excellent. And secondly, just to kind of end on perhaps, what piece of advice would you give to a young person who is starting out? Perhaps they're in college, they want to know, what piece of advice would you give to them?
Keep your doors open. I think the really important thing is keep your doors open, because what you're working on now, or what you might not have interest in now, not necessarily space, would come back to you, or it would show up in the next few years. So I think I'm going to use an analogy my mum used. So when we were in secondary school, we had to decide if we were going to go STEM or non-STEM. She said, go STEM, because if you're in STEM, you can always go non-STEM. But if you've gone non-STEM, you can't go back to STEM after that. So that's why I went with STEM. And then obviously I fell in love with STEM so far down the line. So that's why keep your doors open. If you're unclear on what you want to do, keep them open. And then you'll be able to, they will come to you at some point. And then from there on, you can then really specialize and go for it. But then, yeah, keep your doors open and don't worry about what other people think. Just have confidence, absolutely go for it. Nothing to lose.
That's a lovely piece of advice there. So thank you very much. And thank you very much indeed for your time today. As I say, I could sit and talk to you about all of the things you do all day, but I won't, don't worry, I'll let you go. So I just want to say thank you again for your time. And thank you to those of you that are watching. Just a reminder that you can see these live streams all week, and you can contact us on Twitter at UK Space Academy, or you can head to our website, nationalspaceacademy.org, where you can find a form to contact us. Please send us any space careers questions that you may have, and we will do our best to get them into one of the live streams that we have going on for the rest of today and tomorrow. Once again, thank you very much, and I will see you tomorrow.